Schulich Racing is a student team at the University of Calgary that designs, builds, and races a Formula One style vehicle. The vehicle is made up of four major subsystems: the chassis and controls, powertrain, suspension, and electrical. In general, the performance of each of these subsystems affects the overall performance of the vehicle. Each year, the team strives to make changes to the previous design in hopes of better performance at competition. One of the questions that the team is faced with at the beginning of each build cycle is how do you determine which changes will most effectively improve the performance of the race car? To answer this question, the Schulich Racing team has asked us to create a lap time simulator.
A lap time simulator is a tool that is used by motorsports engineers to estimate the performance of a vehicle based on its geometry, engine, and suspension characteristics. It uses fundamental kinematics equations combined with empirically determined values and formulas to simulate a vehicle on a track. By tailoring the lap time simulator to the formula team, certain vehicle characteristics can be taken into account, such as the mass, track width, wheelbase, and center of gravity. These capabilities differentiate it from other existing simulators.
When the car accelerates, this causes the weight to transfer from the front wheels to the rear wheels. This simple process relies not only on geometry, but also on the tire compound, which can be correlated to the Pajega tire model. Using experimentally derived constants, we can convert vertical loads to longitudinal and lateral forces at the maximum slip condition. For any given test track, the vehicle is not only accelerating, but it's also braking for a significant portion of time. These forces can be calculated using the formula team's current braking setup, taking into account the specific calipers and rotors used. At high speeds, the car is limited by the maximum torque the engine can generate, which can easily be fit into a curve from dynamometer testing. This can be used as a comparison to account for power limitations. For the simulator to be effective for years to come, all the input values can be user-defined and easily manipulated. For this, we want to use a language that most engineering students are familiar with. MATLAB is useful in that it is very easy to learn, but it's also capable of running our operations.
Using this lap time simulator, Schulich Racing will be able to make informed decisions at the beginning of each build cycle. There are four main ways that this tool will improve team performance. The first is cost-effective projects. By knowing which projects will make the most impact on the performance of the car, the team will be able to identify which projects to concentrate on. This will improve project quality in the long run. The second is time savings on less efficient projects. Projects that have a smaller effect on the performance of the car can be reused or recycled with little to no changes. This will save time for other more important projects and testing. Number three is increased performance of the race car. The team can focus on expanding the aspects of the vehicle that they know will have the most impact on performance. This will lead to improved subsystem design, integration, and overall a better performing vehicle. Number four is educational value for new racing team members. Newer members can use the tool to investigate what the important parameters and characteristics of the vehicle are. This will help them more quickly gain an understanding of what type of projects are most beneficial to the team.